Welcome to this SAT Advanced Algebra review. In this video we'll focus on the sum and product of the roots of a quadratic equation, also known as Vieta's formulas. We'll begin with a quick review of the key concepts, then work through several SAT-style problems step by step, explaining the reasoning and strategies you can use to solve them quickly and confidently. Consider a quadratic equation in standard form. The solutions, or roots, of the equation represent the x-intercepts of its graph. We'll denote these roots as R1 and R2. Rather than solving the equation completely, Vieta's formulas allow us to determine important relationships between the roots directly from the coefficients. The sum of the roots is given by R1 plus R2 equals negative b over a. The product of the roots is given by R1 multiplied by R2 equals c over a. These two formulas provide a quick way to analyze quadratic equations without factoring or using the quadratic formula. On the SAT, recognizing and applying these relationships can save valuable time and simplify many algebra problems. Let's begin our practice examples with a problem which asks to find the sum of the solutions of a quadratic equation with fractional coefficients. To begin, compare the equation with the standard form to identify the coefficients. Next, recall Vieta's formula for the sum of the roots negative b over a. Now substitute the values of a and b into the formula. Simplifying, we find that the sum of the solutions is 7 over 6, so the correct answer is choice C. Notice that we found the answer without solving the quadratic equation. In the second example, we'll use the sum of the solutions to find an unknown coefficient. The question asks to find missing coefficient k of the given equation given that the sum of the solutions is 4. First, we identify the coefficients. A equals 3, b equals k and c equals negative 14. Next, recall formula for the sum of the roots negative b over a. Since the problem tells us that the sum of the solutions is 4, we substitute that value into the formula above. Now solve for k by multiply both sides of the equation with negative 3. Therefore the correct answer is negative 12. In this example, we'll use Vieta's formulas to find the sum of the reciprocals of the roots. Rather than solving for the individual roots, let's first rewrite the sum of the reciprocals of the roots. By finding a common denominator, we get an expression that have sum of the roots at the numerator and product of the roots at the denominator. Now we can use Vieta's formulas to find each part of the fraction. First, the sum of the roots is 11 over 3. Next, the product of the roots is 2. Finally, substitute these values into the rewritten expression. We obtain that the sum of the reciprocals of the roots is 11 over 6. Therefore, the correct answer is choice B. In this next example, we'll solve a problem that connects the sum and the product of the roots of a quadratic equation. In the given quadratic equation, the sum of the solutions is equal to twice the product of the solutions. What is the value of missing coefficient b? First, identify the coefficients as 3, negative b and 12. By Vieta's formulas, the sum of the roots is b over 3 and the product of the roots is 4. The problem tells us that the sum is twice the product, so we can write b over 3 equals 2 times 4. Solving for b by cross-multiply, we obtain that b is 24. Therefore the correct answer is 24. In this example, we'll solve a quadratic equation in which one root is a multiple of the other, by combining algebraic reasoning with Vieta's formulas. The question states that one solution of the given equation is 3 times the other. What is the value of c? Since one solution is 3 times the other, let's represent the roots as r and 3r. Now recall again that the sum of the roots is negative b over a, which is 12. Adding our algebraic roots and solving for r, we get that r is 3. Therefore the two roots are 3 and 9. Next, use the product of the roots c over a. Since a equals 1, the product is simply c. Multiply the two roots, we find that c equals 27. Therefore, the correct answer is choice C. Another common SAT example requires using both Vieta's formulas for the sum of the roots and the product of the roots. In this problem is given that the sum of the roots is 3 and asked to find the product. Start by identify the coefficients of the quadratic equation. Based on the Vieta's formula, the sum of the roots is m over 4. Since the sum is 3, we can solve for m and get m equals to 12. Now, using product of the roots formula and replace m equals 12, we find that the correct answer for the product of the roots is 7 over 4 or 1.75. When tackling quadratic equations on the SAT, utilizing Vieta's formulas can offer a few distinct advantages over solving the equations directly. First, they provide direct solutions. If a question asks for the sum or product of the roots, these formulas allow you to find those values immediately, without having to calculate each individual root first. Second, they improve time efficiency. By skipping the process of factoring, completing the square, or using the quadratic formula, you can save valuable time under strict test conditions. Third, using these formulas leads to fewer calculation errors. Reducing the number of arithmetic steps minimizes the risk of sign errors or mistakes when simplifying radicals. Finally, this method handles messy roots easily. Even when the individual roots are irrational or complex, the coefficients themselves are typically integers, keeping the calculation straightforward.